Hi guys, good morning everyone. Okay, so yesterday we were discussing about the images, right? So we need to discuss about the tags, okay, tags part and image layer part. Okay, so in real time, how it will be configured. Before that, let me discuss about tags. Okay, so like internally, for example, we we have an our own Docker machine. Here we install Docker. Okay, and this is a Docker engine, and we are creating containers. And when we are creating containers, if we install anything inside that machine, okay, so any changes has been done, then we can take the image of the existing container. Yesterday we discussed with the command docker commit container ID and the image name, right? So in real time, the whatever the image is there, for example, I am doing docker pull CentOS. So it is getting, let's say, some around 80 MB of size. So with this image, I created a container. So I created a container. This is a container, and inside this container, let's say if I installed yum install IP-utils. Okay, some package I installed. Then this size is around example 20 MB. Then by default base image is 80 MB and this will be 20 MB. So total it became 100 MB. Now what I'll do, I'll create an image with this container, and that image again I can store inside the central repository. Okay, so in a private repository, whether a Nexus or JFrog Artifactory, I can store. And again, what I'll do, I'll install uh, yum install some other package. Okay, let's say HTTPD I installed, and this is a 90 MB of size. And when I install this package, again it's become 90 MB. So this one, again we can create an image, and then again we can store inside this is a new image. Okay, so when we are creating these images, we are going to create as a versions. Okay, this may be version 1 when I'm creating image, and this may be version 2, right? And version 2 images will be available. So while creating images with this container docker commit container ID and the image name what I want to give, then I'll give versions in this way, v1 v2 something like this I'm going to give. So yesterday, to store those images in the docker hub, so I gave this way the registry name. So in real time you need to give what is your Nexus or JFrog URL. That name you need to give it here. Then only when you do docker push, then it can able to push to that specific artifact repository. So this way we can create images. So for the first time I create this way. For second time again I'll just use instead of v1 v2. So like this multiple versions we are going to create. So basically this the latest image contains, it's like a layer. So this is one layer because you installed one package and you created an image. So when you used the CentOS, it's like a base image. On top of that, you install one package. It is added another layer, and again you install one more package, and you created an image, and that image contains another layer. So like this, it is going to create multiple layers. Okay, so image contains of multiple layers. Like if you don't use CentOS, let's say if you are using Docker pull Jenkins, to create Jenkins, first of all, they might use one base image. On top of that, whenever they installing some software, they might be created some multiple layers. So for example, let me create any container now, or even if we pull the Docker image also, we can able to see no need to create containers. So why we are discussing these layers? Because in real time, your responsibility is to reduce the Docker image size as much as possible. Okay, so always recommended. It will be very good if your Docker image size is very less. So when you are creating an image, so you need to make sure that it contains very less size. Okay, so you should not install multiple packages unnecessary. So here, this is a Docker host machine, and here let's say I'll do what, Docker pull Jenkins. I'm not creating any container. I'm just pulling the image from the Docker Hub. If you see, these many layers are available. For every layer, it is creating one ID. Understood? So these many layers is providing by the Jenkins. So for every image means those many times it got recreated. When it was starting, it was created from that time onwards till now. So it got recreated, and this image was created, and for every time they might be added some new software or might be done some changes. So these many layers is available. Same way I'm talking here. So it is going to create a layers to your image. So the same image, when you store in the Nexus repository or artifact repository, the same image, for example, if I give Docker pull this image name this way, then it is going to get all the layers and it will use this image inside this machine. If you are using Docker run -it, um, name of this container one, and image name version 2. In this way, if you are using, then it will create a container by using all these layers. Let's say you don't want, for example, you don't want to go with version 2. If you are using version 1, then in this version 1 image, you don't get HTTP package, because in the version 2 itself, it contains HTTP changes are available. So in version 2, you don't, in version 1, you cannot able to see HTTP package will be available. Okay. So now let me try that. Okay. So now what I'll do, I'll take one image to create the container, plain base image I'll take, like CentOS. Yum, uh, sorry, Docker run -it CentOS one. This is the name I'm giving, and this is a image. CentOS is the image, and I would like to go inside this one. Okay. Oh, service Docker status. Docker login. Am I logged into the correct machine? Docker images. Yes. Okay. Docker run -it name CentOS one. CentOS. I did not give name here, so it is taking this as an image. It's created because CentOS image is available in the local itself. That's why it did not pull from the Docker Hub. Now, this when I'm using CentOS by default, if you see here, the image size is 215 MB. Now I'm going to install some package inside this, right? Let's say yum install tree. Tree. This is one of the package to get the tree command so that we can see the directory in a tree structure. So that is one of the package. So now I installed one package, and the size of this package is around some 59 KB. It doesn't show much difference. So what I'll do, yum install IP -utils or net -utils. Hmm. Let me install some VSFTP package, FTP server. Okay. So now I install some other package. This is also not much big size, but it's okay. So overall, some 480 KB is there. Now I'll come out of this container. Now I'll create an image from this container. Docker commit container ID. And this time I don't want to give the name of the repository because I don't want to store in the remote repository. Let it be in the local itself. So now CentOS or maybe container one, and this way I'm giving version. This is as in V1. It's created. If you check Docker images, so this is a container one and the image name, and this is the tag is the version one. Now what I'm going to do, I'm going to log in once again. Docker ps. Let me log into this container once again. Docker exec.
So already it increased from 215 to 247 maybe MB.
No, it's still in the 215. Okay, yeah, this size you're talking. Yeah,
Yeah.
it's reached to 247 MB. The latest image size is 247 MB. Now, previously it was 215. Now it's showing as in 247. So now again I'm logging in, and this time I'll install yum install. I'll do nginx. So it contains a lot of packages, so size might be also huge. Maybe 30 to 40 MB it is going to take. And etc init.d nginx status. I think they removed it from previously. It used to able to get it from here. Okay, anyhow. So nginx is also installed. Now let me come out of this one. Now let me execute the same docker command to create the image, but this time I'm going to give version 2. Okay, so it's created, and if you see docker images, and this time if you see 290 MB, and this is an image name is same, but the tag is different. So for this tag, you can able to see the size is this one because this contains additional package called nginx. So when you want to create a container, which tag you want to take, if you are taking this tag to create a container, then you don't get nginx package over there. And if you use this tag, then you'll get everything. The first package is what we installed, tree command and vsftp package, and along with that you are going to get nginx also. So now let me create a container with this one, and let me see whether nginx package will be available inside that container or not. Docker run -it hyphen name test, and container 1 v1 bin bash. So this is the image name, and specifically I'm giving v1. Sorry, hyphen. It's available. I created a container now, right? So now uh, here I'll try to do yum install vsftpd. So it's telling already it's installed. You no need to install because vsftpd is already there. Yum install and tree command. This is also already there. It's showing already installed. I'll try to install nginx. Yum install, or let me check whether we can get rpm command. Yes, rpm-qa grep-i nginx. Nginx is not available. rpm-qa is a command in the Linux to get all the installed RPM packages from that machine, and I'm filtering with grep to check whether a specific package is available or not, installed or not. And if I check vsftpd, so this package was installed, so that's why it is showing this RPM package was installed. So if you understood, so this image contains only tree package and vsftpd. Nginx is not there. So this way we can create tags. Okay, so here if you go and check in the Docker hub also, for every images whatever they are providing, there will be a tags. Till now, till yesterday we were using docker run-it and the image name. I'm not specifying any tag over there. It means what? It will take the latest one, whatever is the latest one will be there, it is going to take that one. Let's say if I go to Jenkins, any image, if whatever they are providing, so for every image there will be a tags. So let me open this image. If you see here tags, so this is the latest one. If you don't give any tag, then automatically it will take the latest one. And this is the versions. Okay, 2.60.3, 2.60.3 alpha, and this is the names of the tags. So if you want this specific um, tag, then you need to specify at the time of creating container docker run-it and the image name with tags we need to provide. So as I said, this tags contains some changes. Okay, so there might be done some changes, upgrades, or maybe any fixes, or might be in real time. See, you cannot use the same operating system, right? For example, whatever the base CentOS operating system we took, the same CentOS might be having some vulnerabilities. So you need to fix those vulnerabilities. We need to do some patching. Your containers also should be patched. Means whenever we are using this CentOS image, it should be patched, because maybe in CentOS, if you are those who are worked as a Windows administrator, Linux administrator, you might know, right? Like every quarter or every half yearly, we are going to patch our virtual machines or physical servers from the operating system. Like even your Windows machine laptops also, if you connect to the Wi-Fi, automatically it will get updated. Sometimes whenever you're turning off your laptop, it will say don't turn off, it is getting updated. Same way here, CentOS, whatever the base image you're using your for containers also, it might have some vulnerabilities. So in real time, your containers will be scanned. I will tell you when we discuss about the like real time project. At the time, I will tell you how it will be scanned each container. So the scan will detect the problems like your container is having the image, whatever it is using, it is having some vulnerabilities. So we need to fix them. We need to patch them, right? So that's why the image, the like when you do patching means new packages will be installed. So when new package will be installed, then it will be added as a new version. Same way here also, they might be added some feature inside it, or they might be upgraded it. Due to that, it's changes. Okay, so but how this will work in the real time? As of now, I created a container and I show you the difference by installing two different packages, and I created images with that. Each package when I install, I created separate image and gave versions. But in real time, we don't connect to containers and we don't do that. Basically, how it will be, uh, whenever the developers are writing the code, it will be code check-in is going to happen, and then if webhooks has been configured, then or based upon PolSCM or webhooks, then Jenkins will connect to the GitHub or Bitbucket repository and it will clone the repository. It's a CA job, build job. Okay, it's a CA job is going to execute it, and this is going to be a pipeline. And here in this pipeline, there will be multiple stages will be there. First, it will be like uh, Git clone is going to happen. Second stage will be Maven build is going to happen. Maven, if it is a, in case if this is a Java project, Maven build is going to happen. Then once it is built, artifacts gets created, whether it's a jar or var it gets created. And this jar or var, okay, with the help of this jar and var, the third stage will be create Docker image. So this by using this var file, we are going to create a Docker file. Okay, Docker image we need to create. So with the help of Docker file, we are going to create an image. Mostly that we'll discuss tomorrow or maybe day after tomorrow about the Docker file. So with the help of Docker file, we are going to create an image. So the Docker image contains this var file. This var file will be inside the image, so that when we use this image to create a container at the runtime, this application is going to run. Okay, so image will be created, and fourth stage it will be push the image to Artifactory, whether it's an XS or JFrog, anything. So push the image to Artifactory, or it can be any cloud, ECR, ACR, or GCR, any cloud repositories. It is going to push. This will be available inside the Jenkins pipeline as a CI job. So CD job, what it will be there? Jenkins CD job separate, it will be there. You can use only take the image from the Nexus repository and deploy into the some orchestration tool like Kubernetes or Docker Swarm, whatever you are using. Okay. So here, whenever they are doing this, it is getting created image and pushing it to the Nexus repository. So let me delete this too. Right. So it is getting stored. Assume this is a JFrog, and Docker images it is storing here, which contains the var file if it is a web application. Now again, they this what they'll do, this Docker image we can deploy on some environment, so the testing team can do the testing, and once they confirm, like if they find any issues in the logic of the code, then again they'll get back to the developers, and developers again they'll do some changes. So whenever again they're doing some changes, again the Jenkins will pick up the code, and again it is going to create an image, and again that image is going to have a different version. So in this Jenkins job is executing, here we are going to write a logic, like whenever it is getting triggered, it should store with the, here manually I'm giving version 1 version 2, but here whenever it's creating Docker image, automatically it should store as a versions. It cannot override the existing one, because we want history of the each and every Docker image in the Artifactory. So in the Jenkins file itself, we'll define, for example, based upon the build number, it will take the build number and will create it as a version tag, and will store inside the Artifactory. So that way, every time your Docker image is going to be created, and it contains multiple changes, like multiple layers. Just now I told you, like manually I shown you how to install a package, and there will be multiple versions. So here also this Docker image contains multiple versions, because basically in the image only thing is changing, in the application level the var file is getting changed. So next time whenever the Docker image is getting created, it is going to get the latest var. So then we can decide, once the testing team confirms, the same Docker image we are going to use it inside the different environments like staging, pre-prod and prod environment, because once it is, we find that it's stable, perfectly works fine and confirmed by the testing, functional testing guys, then we can use the same Docker image in different environments. So but remaining Docker images will keep it as a history, right? So this is how the Docker images are going to be built in the real world with multiple images. So when we talk about a Docker file, that time I will explain in more detail, like how we write Docker file, because in real time we use Docker file, and in the Docker file itself we'll define how to copy this var file into an image, and how it gets executed at the time of runtime, so that application should start automatically when I deploy this Docker image, that we'll discuss at the time of Docker file. So understood, right? This is about the layers and tags. So here also, it is going to store as a tags. Docker image, it just will be stored in the Nexus repository as a tags. For example, it is one of the microservice. So it is going to store as an, what are the build number you are using, in case that build number 1, 2, 3. So we can pick up any build number, latest one, and we can able to deploy onto any of the environment. So this is about the tags and versions. And yesterday when I was talking about Docker login, right? So I did not give anything, just I used a Docker login. If you want to connect to the default Docker hub, then we should use this Docker login so that it will connect to the central repository and we can able to push the images. But in your organization, we don't use Docker hub. We use our own private repositories. At that time, you should use Docker login and the URL to connect that Nexus or JFrog, whatever the URL will be provided by the tools, guys. If you are managing that Nexus or Artifactory as a DevOps engineer, means you build from scratch, then you should be having authority. Guys, can you please go on mute? Those who don't want to speak. Okay. So in some organizations, you are not going to manage the Nexus or JFrog artifact. There will separate tools team will be there. Just they will create access to us, and we just use. They'll create one repository for us, and we use that repository in our Jenkins pipeline to push the images. In some organizations, we are going to build it from the scratch, and we are going to have authority to manage it. It depends. So you need to provide that URL if they give with any port number. Okay, URL with any port if they give that URL port you need to mention, and what are the credentials you provided. It will be always domain credentials in the real-time organization. So you need to provide your domain credentials so that from this machine you can push the images to the Nexus or JFrog artifactories. Okay, any doubts? So this scenario sometimes see,
Uh,
yeah, tell me.
can you repeat this again, the command, the Docker login URL port?
Yeah, actually, when I use Docker login, it is asking credentials, right? Actually, it is showing login succeeded. Yesterday, I executed this command. It was asking me credentials. So which credential it is expecting by default? It is expecting Docker Hub credentials. So I have already Docker Hub credentials. So I provided there. That's why when I executed Docker push the image name, automatically it knows that, okay, I connected to the uh, public Docker registry. So I should push the image to that registry. So that's what happened yesterday. But in real time, you don't use Docker Hub. You use your own private registry. Like it can be, as I said, Nexus, JFrog, or it can be ACR or ECR or GCR. These are the container registries inside the cloud. It can be anything. So that URL you need to give. For example, Azure dot some ACR in Azure, it will be like Azure.io, something like this will be there. So this URL we need to give, and credentials will be should be provided here. Okay.
Praveen, one quick
You
question.
had mentioned
Hmm.
port
Hmm.
port there.
Port means if it is running on specific port, that service, then you should use port. Or else if they have,
Oh,
if they are giving the URL, so if you are managing, you'll come to know what is your Nexus or JFrog Artifactory URL. That URL you are going to provide here. Or someone else is managing it, they will give you the URL and the repository name. So first you take the URL, you just use the URL to connect it, and the repository name at the time of creating image, you can use it so that it can able to push it.
okay, got it. Thank you, sir.
Yeah, Praveen, one quick question. Earlier you mentioned when you get the Nginx to build the container, you said multiple patches or multiple versions are there. That's why we are downloading all the versions. That I did not get it, because once they do the patches, the previous one should get deleted, right? Because only one latest version should be available. That's what we download.
Yes. So whenever you are doing patching to your machine, obviously the previous version will be not, the latest version will be there.
Yeah, that is correct. But when you install that Nginx, it is showing a multiple lines, multiple multiple packages or multiple images, I believe. That's what it is giving one image ID for each and every version.
You mean to say layers?
Layers, that's true.
The layer not only contains about the patching. Okay, I said one of the example is sometimes if you do patch, that is also become one layer. But they might be installed some other package, or they might change something inside that configuration settings. See, in the previous batches when I was doing Nginx installation, Nginx was not by default was started. So at that time
Mhm.
I was using etc init.t, okay,
Yeah.
Nginx, and then manually I used to start it. But now I'm not doing it. There might be done some changes. So when you're doing some changes, then again you are going to create an image from that, and that image will be new layer. So even though you did not install anything, but you go to some configuration file and you do change it, and you take the
Mhm.
image, and that is a new change, right? So that will be applied to that new layer of that image. So
Okay.
here I'm talking about one thing, just like I would like to recommend here, not only installing the some packages, it is going to have a new layer. Even if you do any changes in the configuration file, and to take effect that you are going to take the image of that container, and that is also will be again another layer. It's not only when we are installing the packages, it is going to create a layer. If you do any simple configuration file changes, and again you take the image, and at that time you are giving v3, okay, version 3 to the new image when you are creating. So whenever you are creating a container with that v3 image, so whatever the configuration you have done in the changes, that will apply to the v3 image. So when you create new container, the changes will be applied. So that is also called as a new layer. Okay, not only when we are installing the packages, it is going to be a new layer.
Okay, got you. So if someone download the image of version 3, so they are going to see version 2 and version 1 also as layers
Yes.
that gets downloaded. Okay, got you.
Yes.
Right, thank you.
Okay, so this is very, very important. Tags are very, very important in your real time, because when you are deploying, you need to decide which tag you need to deploy and what changes will be there inside the tags will be available. Okay, so that you can deploy that specific application on microservice on the specific environment. Okay, so this is about the images and tags. So now we talk about Docker networking. Okay. So till now we were discussing about images. Now we talk about Docker networking. So let us go to the official document. So whenever we talk about Docker network, we need to talk about network drivers. Can anyone tell me what are the network drivers are available? If someone already knows that.
Bridge,
Yes.
You mean Ethernet?
No. Someone telling something apart from Ethernet. Someone said
bridge
something.
network, overlay network.
Reinforcement overlay MacVLAN.
And
Exactly. So those are the network drivers. So to see how what are the networks are available, this is a command to check Docker network ls. So we can able to see our default networks. Okay, here we can see this is the name, bridge, host, and none. These are the storage drivers. Okay, here if you see bridge, host, none, or null. Apart from this, we have many more. Okay, where it is. So we have bridge, overlay, McVLAN, okay, host, and none. These are the network drivers are available inside this Docker.
Is this driver's functionality is like similar, or one driver is having specific functionality?
Yeah, each driver is having specific functionality. Okay. So now these are the network drivers: bridge, host, overlay, make VLAN, and none. Let us discuss about each individual network. So first one is bridge. The default network driver is bridge here. Means when we install the Docker, the default network driver is bridge. So if you don't specify a driver, this is the type of network you are creating. So bridge networks are usually used when your application running standalone containers that need to communicate. Okay. So here,
Praveen,
yep. Just tell me.
so can you just give us an overview of what Docker networking? What is Docker networking? Can you give us overview?
Yeah, that is what we are discussing now. It's not yet completed. I started Docker network just now.
Okay,
So I'm
like
going to explain
basically
you by showing in the
explain too much.
diagram. Okay. Yeah. So in the Docker network, we
Sure.
have these network drivers. So one by one we'll discuss so that you can understand it. Okay. What is Docker network? Okay. Not overview. We are going to discuss very in depth of this Docker networking. So
Sure.
first of
Okay.
all, right? The basic meaning of networking is for communication purpose. That is the main purpose of networking. So here, Docker networking, how we are able to access the containers and how containers are accessing internally, or how it can be accessed through the external world. That is called like Docker networking. So when we install the Docker, like this is your first bare metal operating system. We choose Amazon Linux or CentOS, whatever it may be. Maybe let's say I selected Amazon Linux. This is a virtual machine from the AWS, and on top of that I installed Docker engine software. So this is a Docker engine, right? And this is called as a Docker host. Where you install Docker engine is called as a Docker host machine. So now when you are creating these containers here, how they are connecting, how they are getting connected, because when you install the Docker software, automatically what it is doing, the Docker software is creating a small network inside this host machine. So if you see here, we have a command inside the Docker inspect network, and this is a network name you can give. This is a bridge network. I'm just checking. It's like a describe command. And if you see here, these are the container IPs, and this is a subnet. So this subnet range means it is creating one. Those who are having good in the networking, then they can understand. Those who are doesn't have networking, it will be tough to understand networking concepts. So you should have networking knowledge when you want to learn Kubernetes or Docker. Okay, because this is something like the infrastructure part only. Okay, so this is a subnet part. So this subnet and this is a gateway. So what it is doing when we are installing this Docker software, it is creating a network for internally for its Docker. Okay. So what it is doing uh, here, this is a network, and for this network, it is creating a gateway. This is a gateway IP. So the first IP from this subnet, it's using class B, and from this subnet, it is using the first IP as a gateway. So here it is using the gateway IP address, and from container, it is going to use 172.17.0.2 because already one is used from this network range. So for next containers, it is going to assign this range 2, and for this one, it will be uh, 0.3. So this will be 0.3. So what it is going to do, your AWS virtual machine is having some network range. So this is my private IP range where it is. This is the one, and this is the IP for your virtual machine. Now this gateway, what it is doing, this is going to communicate. This gateway is created to access with the this specific Docker host. If you sit in your virtual machine, right now I'm inside the virtual machine. If I check with ifconfig, you can able to see this is the IP range Docker 0. This is the gateway between inside your machine's containers and your host machine. Okay, this is a host machine IP address. So internally, when we install Docker software, it's created this network, and this is a gateway to communicate to this network. That's why when I accessing this container Nginx image, the Nginx container, so it comes up to here. From this machine, it will go inside with this gateway. So the request will come here when we are assume we are in the office and we are in the private network. So in my office, when I'm trying to access this container, let's say it's an Nginx image. So now it will come to here, and from here to here internally it will go to this gateway. From this gateway it will go and access this specific container when we are trying to access it, and same way this one also. So this is the bridge it is going to create, and this bridge is having, this is the IP address, is a gateway, and it is communicating to this machine. So your virtual machine in the AWS also having a subnet. So if you have another virtual machine, that machine might have 172.31.39.183, something like this. Okay, but internally this is a Docker host, and inside this, to communicate your containers, Docker is installing this network, and it's creating this as an gateway to access it with the your Docker host. So Docker host, with the help of Docker host, you can able to access. So that is the purpose of bridge here. Okay, the default network driver. So bridge network are usually used when your applications run in standalone containers that need to communicate. So standalone machines means this is an independent machine. So in this independent machine, it is going to able to communicate with this machine only. Understood, right? The purpose of bridge. And in the Docker host machine, if you execute ifconfig, you can able to see these are the two networks. Means as of now, two containers are available. So this is the IP address virtual Ethernet card for these two containers it got created. And inside these two containers, let's say if I go and log in and see Docker execute -it, I'll check the IP address. By default, it is will be not available. So yum install net-tools. I'm going to get ifconfig command. You see, for the first container, this is the IP address. Okay, 172.17.0.2. So for the first container, randomly it will give the IP address. For the third container, it will be 3. Fourth, it will be like that. So what is the range? It's a 16 series, means what? 65,000 IPs it can be assigned, means 65,000 containers also you can create, because those many IPs will be available. So this is about the bridge network. So someone asked me, what is this networking? Is it your doubt cleared? The purpose of the Docker networking is how your containers are accessible to the external world. So for that, in the Docker, we have multiple network drivers. So which network driver is suitable for you, you can use that. So by default, it is using, when you install Docker inside your machine, it is taking the bridge as a default network driver. Is it your doubts clear? Someone asked the overview of Docker networking.
Yes.
Yep. And second one is
So
host.
one question.
Yep.
Okay, open the paint.
Yeah.
Yeah. So in the subnet range, okay. So for this bridge, there is a subnet range which is /16. So in this time, the first IP will always be reserved for this bridge, this network, right?
Yes.
Okay.
See, it's not only
So
first
okay.
IP. Randomly, sometimes whenever you're creating network, it can pick any IP, but mostly it will pick first IP, or sometimes it will pick last IP also. 254 IP also it can pick, or if you want to specify the gateway IP, you can also specify. If you don't want one, if you want to specify your own IP like 0.5, 0.6, Then also at the time of creating bridge, you can specify I want this IP should be the gateway. Then it will take that IP also. That I will show you tomorrow, like how to create our own network. So this is the default network. When we install Docker, it's created one default network, and inside the default network, the containers are getting created. But I don't want 170.17 series. I want my own series, maybe 192 series. So for that, I will create a network, and in that network, I am going to create the containers. So we can have our own network separate, and we can use that network to create the containers also. And instead of randomly assigning, dynamically assigning the IP addresses, I want to assign specific IP address to a container. That is also possible. That everything we'll discuss tomorrow. Okay.
Another thing, so
Yeah.
like we do in EC2 instances, okay, so if there is any IP which is coming from external world, so we are
Hmm.
allowing it, okay, so we are configuring it based on that. So
Hmm.
similarly, should we do it in containers?
You mean to say
No, right?
internally inside this machine?
Yeah. I mean, so like we do for EC2 instances, right? So is there any way to do it for containers? Should it be done or it should not be done?
What you want to do?
Or EC2 takes care of?
No, what you
I
want to do?
mean, some Linux instance, which is some Linux instance, okay, for Linux
Hmm.
instance, there is an IP, okay, which is coming from external world. So we are
Hmm.
allowing that IP, okay, right?
Hmm.
So we are configuring it based on that. So in Actel or somewhere,
Hmm. Hmm.
okay. So similarly, so when we want to connect to my container, okay, from external world, so should there be
Hmm.
any configuration done for that particular IP?
From the host level itself, you can configure. If this is an AWS machine, in the security groups, you can configure it, or
Okay,
you can configure it in the network NSG rules also, you can configure it. Or else if this is a virtual machine in the
okay.
VMware world, then you can configure it in the firewall, and firewall rules you can be able to configure. So because
So it should
first
be
it
done
will
at the
submit to the
host
host,
level.
and from host it is going inside, right? So host level itself, you can block whichever IP you want.
Okay. Okay, so there, I mean, there is nothing like container level we should do. There is nothing like that, right, sir?
No, because container level containers are not immortal, they are mortal, right? So anytime they can die, the again new containers gets created in the real world. So again new containers gets new IP, so you cannot configure it from the container level.
Understood.
So the second driver is host. So for standalone containers, remove network isolation between the container and the Docker host, and use the Docker's networking directly. Means if you are using a host network driver, then you don't have this. It is not going to install or configure this network layer here. So directly your containers are going to use your Docker host network. Like for example, uh, this will be the containers are going to get created, and there will be no network layer will be available here. And this is a Docker engine, and this is a uh, OS part. And what are the subnet is there? From this subnet, it is going to assign the IP address. So it is going to take host subnet 172.31.39.184. This way, it is going to assign the IP address. So there will be no network layer will be there. So there is no gateway required, and separate network series is not required. Directly, it is going to take the IPs from the host subnet. From that range, it is going to assign the IP addresses. This is about the host. Basically, we don't use them. And overlay. Overlay networks connect multiple Docker daemons together and enable SWAM services to communicate with each other. So this one will use um, like if you have this machine, single machine, but in real time, what are the contents are running here. If something happens to this virtual machine, whatever is inside this virtual machine also, all the contents will be stopped. So your application will be stopped. So we don't use in as a single container, right? So what we are going to use, we are going to use it's like a multiple virtual machines this way. So all together we are going to configure as an overlay network. So this overlay network we do when we want to configure Docker Swarm. So what is Docker Swarm? It's an orchestration tool, right? So when we discuss about the introduction, Docker Swarm and Kubernetes, Cloud Foundry, so these are the orchestration tools. So what it will do is if you have multiple machines, by default internally they will not, this container cannot able to communicate to this one cannot able to communicate to this one. But if you configure two replicas inside this single virtual machine, if this virtual machine goes down, then where is the high availability for your application? So that's why what we'll do, we'll take multiple virtual machines when I want to run an application, and each container is going to, for example, I mentioned three replicas. So one will be created here, another will be here, and another will be here. And all together, these three, it is going to have the access. Okay, so this way, on top of this your application is going to running, means it can be accessible. If this virtual machine goes down, still you have two containers are running in two different machines. And if this is also goes down, this will be available. So this way we can achieve high availability. But how this will be communicated? With the help of this overlay network. If you configure overlay network, then this three can able to access. So when you are deploying the application, it will be running on this three. It's like those are from the network Windows background or Unix background, like Veritas cluster or Microsoft cluster for your servers. For example, those are from the Oracle DBA. In the Oracle DBA also we have Oracle Rack or Oracle clusters we are going to configure, right? This is a cluster, we call it as a cluster. So this with the help of this network, they can able to communicate this all machines. Okay, so that we can configure with the overlay. When we configure Docker daemons, means what? In each machine, Docker daemon is going to run. Where when you install Docker here Docker service is running daemon. Here also Docker daemon will run. So all these Docker daemons can run in a single cluster. That way we can configure with the overlay. And McVLAN networks allow you to assign a MAC address to a container. Sometimes in real world, some of the in the previous scenarios, the applications was configured in such a way that that application will run on specific MAC address. Means in the application, if it is used, if you are using the IP address, it is not going to run. If you are giving the MAC address of that machine, then only that application will start. So if it did not find that specific MAC address, then that application is not going to start if it finds a new MAC address. So in this scenario, so McVLAN, what it will give, network allows you to assign a MAC address to a container. Okay, so making it appear as a physical device on your network. So your application assumes that, okay, this is a physical device and it contains a MAC address, and that MAC address will be registered with that application, and then it will run. It's very old legacy applications. Sometimes depend upon that coding it requires. Okay, most of the cases, no one will use this option, because nowadays, if you are going with specific options, then it will not work properly. Okay. So none means for this content disable all networking usually used in conjunction with a custom network driver. So none means there will be no networking inside your Docker machine. Okay. So these are the Docker networking concepts. So tomorrow I will show you how to create bridge networks and our own bridge networks, how to create, and inside that network how we can specifically create the containers, and how I can assign specific IP to my container. All these things we'll discuss in tomorrow's session.